The respiratory system has a couple of functions, and it's based on one major survival need. And that survival need is oxygen. And we've covered enough ground in terms of the other systems for you to understand where and why we use oxygen. It's related to production of ATP, which we need for the nervous system to work properly, which we need for the muscular system to work properly, all while using the sodium-potassium pump. Various things in the body, we have to have oxygen for this need. We're aerobes after all. The basic anatomy of the respiratory system starts with the nose and to some extent the oral cavity or the mouth, moving through where you can see we have the nostrils and the nasal cavity, oral cavity, through the pharynx, the larynx, the trachea, and into the lungs. And within the lungs, we have various breakdowns based on conduction or gas exchange. So to start, primary purpose, as we've said, is to deal with the survival need of oxygen. So the whole point of the respiratory system is to oversee gas exchange. And it's specifically gas exchange within the lungs. So that means between the body and the external environment. So we have to get oxygen out of the external environment into the body. We also, notice it says gases, that means we also have to get rid of CO2 from the body, which is a byproduct of all of the activities we do, that breakdown of glucose to supply energy to get ATP. So we have to get oxygen in and CO2 out. Now the primary function besides conduction of those gases to the location of exchange is to, notice, purify, warm, and humidify. So this is actually why you should breathe through your nose and not your mouth most of the time. Now, the nose, first and foremost, is our visible part of the respiratory system. We enter, so it enters through the nose, so do me a favor, real quick, pause, breathe in, breathe out. Okay, we have two nostrils separated by the septum. Okay, remember in terms of the bones, you have the vomer coming up. We also have the various internal concha, or the inferior concha. And the concha are actually what allow the air, as it enters through our nostrils, to be warmed. It forces it to literally blow over some of the structures so we can get things out of the air. So we're purifying it, we're trying to get particles out. This is partly also why you are lined with mucus, because that mucus captures that stuff, and then that mucus is literally led to the throat where we swallow it, and all of that stuff, whether it be bacteria or dust or whatever, is sent to our stomach, and our stomach then serves part of that immune system role because the acid will literally kill the bacteria, ideally. In any case, back to the nose, you can see that we have the oral cavity is right above the palate, so here's the extension of the maxilla, and then the palatine bone, right? And the nasal cavity sits right on top of that. So you'll notice there's not a lot of space between your nose, your nasal cavity, and your oral cavity. But notice that all of this structure is what literally increases surface area, increases air turbulence, making it easier for us to purify, humidify the air before it enters the lung. In addition, as I've already mentioned, it does trap a lot of incoming stuff because we don't want that down in our lungs. So if we trap a lot of those foreign particles, they don't end up in our lungs, and that's kind of the point. So you can see the sinuses, various sinuses here. You can notice here's where our olfactory cells are, so our ability to smell. All of that ties in. Now, the paranasal sinuses are the ones that are, we've talked about that when we talked about the skeletal system. You have the primary ones, frontal, sphenoid, ethmoid, and the maxillary bone. And literally, we talked about it in terms of lightening the skull. We talked about it in terms of acting as resonance chambers for speech. But this right here, this production of mucus, is literally to help trap foreign particles. Don't forget that part. So that's really the primary purpose at our level when we talk about the paranasal sinuses. Now, the next step is obviously the pharynx. Okay, the pharynx is this area right here. Okay, so the pharynx has three parts: naso, oro, laryngo. what it boils down to is the pharynx is where the oral and nasal cavity come together, and it creates a passageway to the larynx. So both food, air, everything has to pass through these two cavities and they meet. The primary function of the pharynx, this is where the tonsils are located. Keep in mind the tonsils have a role within the immune system to help to, they quite literally just gather any pathogens or foreign particles from both our food and the air before it's able to go down into our body. So they're kind of like a line of defense within and surrounding the pharynx. So they help to remove all that stuff. They're just, think of it as kind of like you have to have the right name, the password or something like that. Now after stuff passes through the pharynx, then that's when we hit the larynx. Now the larynx, right here, actually plays a real important role and is what, if you inhale when you should swallow, what leads to issues. Because one of the points of the larynx is to route food and air into the proper channels. So we have to be able to get air into our lungs without getting food there, and we have to get food to our stomach, etc. Now this is also where we find the role in speech. In other words, within the larynx, we have the vocal cords, we have the epiglottis, which is responsible for either covering the trachea or covering the esophagus to make sure food and air go to the proper channels. It's very hard and structured. You can actually kind of feel it at the base of your neck. So if you go up underneath your tongue, you can kind of feel that point. In addition, since when we look at the larynx leading to the trachea, again, notice this part is the larynx here. This is that area, and a couple of students, you can probably correct me, but this area right here, this is where a lot of the emergency tracheing can be done, and in fact it might be where normal tracheing is done. So they cut into here to help get the tube in if people are put on a respirator or things like that. But simply notice the different structures of the larynx. The Adam's apple, typically only apparent in men, so that's one of the ways you can recognize male and female. Again, it's one of those secondary gender characteristics. That's about it. The main thing to remember about the entirety of the system as we work our way down is to get air that is moist, purified, down into the lungs where we can have the gas exchange. The whole point of the system. That's really what's going on. So, trachea. The trachea creates permanently open passageways that are held open by the cartilage. Remember that cartilage is very structured, can withstand a certain amount of compression, and so it maintains a constant opening so that air can always get into the lungs. Second thing to note is, remember when we did our histology unit, we talked specifically about the pseudo-stratified columnar tissue that was ciliated. So we have these ciliated cells, and they beat in such a way as to cause the mucus that lines the passages to come up. So it lines all of this, but they beat in such a way to bring all of that mucus up to the throat so that we can swallow it. So it brings it up here towards the epiglottis area. When it hits that, we can swallow, and we get a lot of that mucus that's in our lungs. It's kind of that final area to trap more foreign particles or pathogens that were missed within the nasal cavity, that were missed by the tonsils, and again, just to kind of trap those things, get them out of the lungs and down into our throats so that we can swallow them. The lungs themselves then occupy most of the thoracic cavity, and this is not something we've looked at too much, but you can see, here's my vertebrae, my heart, we've already talked about the cardiovascular system, but look at how much space is occupied by your lungs. In fact, if you go into this area right behind your clavicle, if you feel down and you push down on that, what you're pushing down on literally is the lungs. So it completely fills that area occupied and protected by the ribs. The base is resting on the diaphragm. So let's go back and look at that original image. So here's the clavicle. Here's my diaphragm. Remember, the diaphragm divides my thoracic cavity from my abdominal pelvic cavity. And you can see the lungs literally sit right on top of that. And they're right here at the clavicle. Structurally speaking, they're identical except that the left has 2 lobes, the right has 3 lobes. And overall, you can see the parts. You can see the 3 lobes and the 2 lobes. And what's cool is the lungs are covered by various structures. We've already talked about the cavities to an extent. You have the visceral and the parietal cavity that the lung sits in. So you have a cavity around each lung. And what is cool is that fluid here helps to protect and cushion the lungs. And it allows the lungs to kind of move and shift without getting stuck. So they keep everything lubricated so that they can move and shift and not literally get stuck and tear or anything like that. In addition, we also have what's known as surfactant that helps to keep the lungs expanded. So the pleural cavity also helps to protect the lungs in such a way that they don't necessarily collapse onto each other, because there's fluid all through the lungs. And this is actually what happens with a collapsed lung, is that fluid within the lungs keeps the lung stuck to each other rather than to the walls of the pleural cavity. And so that's what happens when you have a collapsed lung. Now, going back down to the respiratory tree. So we come off the trachea right here, and we have these permanent openings coming into and throughout the lungs. So they're held open by cartilage, and we work our way down, and you can see we get secondary, tertiary bronchiole, terminal bronchiole. The terminal bronchiole basically end in the primary structure, which is the alveoli. The alveoli right here, these little sacs, are actually where gas exchange occurs, and we'll talk about that in the next section. But that's what's known as the respiratory zone. And anytime we talk about respiration, it's actually gas exchange. So the primary purpose of this whole section was to talk about the conduction system and what has to happen to the air as it's conducted through the body to get to the point where we can have gas exchange.